In this lesson, we are going to know the main components of a renewable energy system and how to size the renewable energy system and estimate the total cost of the system. To better achieve this goal, we are going to see an example of a standalone solar energy system supplying the electrical loads of a typical office. This office is located in the Faculty of Engineering at Misurata University. Talking about the cost of renewables, according to the Renewable Cost Database of Renewable Energy Agency, there is an obvious reduction in electricity cost from renewable energy technologies from 2010 to 2017. For example, there is a 70% reduction in the electricity cost coming from solar photovoltaic systems, from $0.36 per kilowatt hour in 2010 to $0.1 per kilowatt hour in 2017. And there was 30% reduction in the electricity cost from solar concentrated power plants from $0.33 per kilowatt hour in 2010 to $0.22 per kilowatt hour in 2017. Similarly, for the wind energy, there was almost 20% reduction in the cost of the electricity which is coming from offshore and onshore wind systems. In contrast, there was a slight increase of electricity cost which is coming from hydro and geothermal systems. The cost of electricity coming from renewable sources will continue to reduce with an obvious rate according to the Renewable Energy Agency in 2017. Regarding the installation cost of renewable energy systems, it is expected to decrease as well. For example, and according to the International Renewable Energy Agency, the installation cost of the utility-scale solar PV system is showing an obvious exponential decrease from about $5,000 per kilowatt in 2009 to almost $600 per kilowatt in 2025. The first step in installing a renewable energy system is to determine the load requirement. This table shows the load consumption of the office in kilowatt hour per day. So as we can see, we have the load type and the quantity and the number of working hours for each load per day. And by adding all load consumption, we can get the total load consumption per day, which is around 8 kilowatt hour. The second step is sizing the solar panels and the battery system, meaning how many solar panels and batteries do we need in order to meet the load requirement. If we are going to use 8 kilowatt hour out of the battery system, the solar panels on the roof should give us around 8 kilowatt hour to charge the battery system to 100%. According to the Renewable Energy Authority of Libya, the average sunshine is about 3,200 hours per year. That means we have an average of 7 hours sun per day. In these 7 hours, the sun is on the panels. So the panels are producing their maximum power during these 7 hours. So per day, if we divide 8 kilowatt hour by 7 hours, we get 1.2 kilowatts. This is the total watts we need from the panels. If we choose a solar panel of 250 watts, then at the best, we can expect 200 watts out of it. So in order to know how many panels we need, we can divide the total watts, which is 1.2 kilowatts, by 200 watts, which is the output of each panel. Then we get the total number of panels, which is 6 panels connected in series, 250 watt each. Regarding the size of the battery system, it's important to mention that in a standalone solar energy system, we never use the generated energy by the panels directly. The solar panels send the captured energy from the sun to the charge controller. And the charge controller reads what the charge of the battery system is and determines how much it should charge the batteries. So if we are using power during the day, the power comes from the batteries. And the power that comes from the solar panels is directed into the batteries to charge them. Therefore, we are pulling power from the batteries and the solar modules are charging the batteries back up. That's the best way to look at it. So that being said, we only have as much power to use as what's stored in the batteries. As for the batteries, we never want to go below 70% of charge. And this is to save the lifetime of the batteries. So our consumption per day should only be 30% of what's stored in the batteries. Therefore, the size of the battery system should be 100% divided by 30% times the total consumption of the load per day, which is 8 kilowatt hour. That gives us 27 kilowatt hour, and that is the size of the battery system. Now we have to decide on the voltage of the battery system. If we choose a 48 volt system, this means that we need 27 kilowatt hour divided by 48 volt. That gives us around 600 ampere hour out of the battery system. Now it depends on the batteries available in the market and how much ampere hour each battery can produce. In our case, we are going with a 12 volt 150 ampere hour battery. This means we need 600 ampere hour divided by 150 ampere hour, and that gives us 4 strings of batteries in parallel, producing a total of 600 ampere hour. In each string, we should have 4 batteries in series in order to get a 48 volt at the output. So at the output, we will have 48 volt times 600 ampere hour. That gives us 28 kilowatt hour. And our consumption is at 30% out of that, which means it's 8 kilowatt hour per day. Regarding the cost of the system, we can calculate how much each item does cost and add them together to have the total cost of the system, which in our case is around $3,000 US.